I'm now moving on to the factoring homework questions, and for question number 1, I need to find the greatest common factor for each of the terms below. Now for problem number 1, let's take a look at the numbers in problem number 1a. So for 1a, I have 8 and 12. The biggest number that divides 8 and 12 at the same time is the number 4. And if I take a look at the variables, I have a single x and a single x. So since both terms have a single x, I can remove a single x from both of them. And my final answer here would just be 4 to the power x as my greatest common factor. Moving on to letter B. If I take a look at the numbers here, 8 and 12, the biggest number that divides both 8 and 12 at the same time is the number 4. Okay, now let's take a look at the variables. I have x squared and a single x. Now you have to ask yourself, what is the maximum number of x's that I can remove from the same time from both terms? And the easiest way to do that is you always pick the smallest variable. So which one's smaller, x squared or x? Well, x is smaller because it has fewer x's, so I can pull that out. And then let's take a look at the y's here. I have one y here and two y's there. I mean, which one's smaller, a single y or two y's? Well, a single y is smaller, so we always take out the smaller variable when we're finding the greatest common factor when we're dealing with variables. So my answer here would be 4xy as the greatest common factor. Moving on to letter C, let's take a look at the letters first. The numbers first. So I have a 6 and a 3. The biggest number that divides 6 and 3 at the same time is the number 3. Then let's take a look at the variables here. I have x to the power 4 and x to the power 5. Which one is smaller? Well, x to the power 4 is smaller, so we'll pick that. And then there's y to the power 5 and y to the power 2. Which one's smaller? And y to the power 2 is smaller, and that is my greatest common factor. Okay, moving on to letter D. My numbers are 8, 12, and negative 24. And the biggest number that divides into 8, 12, and negative 24 at the same time would be the number 4. And then let's take a look at the variables now. There's a x squared, an x squared. Out of all those blue x's, which is the smallest value of what's the smallest number of x's that you can have? Well, it's this guy right here. That's a single x, so x would be the greatest number. That's the maximum number of x's I can remove. And then let's take a look at the y's. Which one's the smallest? Well, this one right here. This is the smallest here, so that would be y squared. So my GCF is 4xy squared. Okay, let's move on to question number 2 now. Complete each factoring. So over here I have a 6x, and our job is we need to find out what goes in the bracket. Okay, so this 6x is like your GCF, that's the greatest common factor. So all you really have to do is you take your left term, which is 12x to the power 4, and you divide it by your GCF, which is 6x. And after that, you just do the math here. What's 12 divided by 6? 12 divided by 6 is 2. And if I look at x to the power 4 divided by x, that's just x to the power 3. Okay, and you can easily just check your answer if you just multiply this through. If I multiply this through, that would give me 6 times 2 is 12, and x times x cubed is x to the power 4, which matches the statement there on the left-hand side. So my answer is 2x cubed. Let's move on to letter B. And for letter B, I'm given that 8 is my GCF. So this is my GCF right here. So we're just going to divide each term on the left by the GCF. And then we just do the simple math here. The 8's cancel off, giving you a single y. So y would go in the bracket. And 16 divided by 8 is just 2. All right, so my answer is y plus 2. And once again, you can do a simple check by just distributing here. So 8 times y is 8y, and 8 times 2 is plus 16, which gives you that answer over there. Okay, let's move on to letter C here. And for letter C, my GCF this time is negative 9a squared b to the power 4. So I'm going to divide every single term here by negative 9 a squared b to the power 4. And I'm going to divide this term by negative 9a squared b to the power 4. And after that, we just do the simple division steps here. So negative 27 divided by negative 9 would be positive 3. And then a cubed divided by a squared is going to be a single a. And the b to the power 4s, they can just cancel off. And then I have a negative 36 and a negative 9. Negative 36 divided by negative 9 is going to be positive 4. And then you'll see that the a's just cancel off. The a squares will cancel off there. And b to the power 5 divided by b to the power 4 is just a single b. So my final answer there is 3a plus 4b. Okay, let's move on to the next questions in the homework section. Question number 3, I need to factor out the GCF and write prime if I can't factor it. Okay, so if I take a look at the 6 and the 3, the biggest number that divides 6 and 3 at the same time is the number 3. So that right here is my GCF. And then I can divide each term by the GCF. And then ask yourself, what is 6 divided by 3? Well, that's 2, so this would be 2x. And 3 divided by 3 is just 1, so it'll be plus 1. So my final answer is 3 times 2x plus 1. And a lot of these answers you can just double check by just distributing here. If you distribute that, I would get 6x plus 3, which is the original problem. So always double check your answer if you're not sure. Okay, moving on to the next problem here. I have a 24 and a negative 8. So the biggest number that divides into 24 and negative 8 for this particular example would just be would be 8. 8 definitely divides 24 and negative 8. And if I look at the variables here, which one's smaller, x squared or a single x? Well, a single x is smaller, so 8x is my GCF. And then I divide each term by the GCF, and that will give me the expression in the brackets. So 24 divided by 8 is 3, and x squared divided by x is a single x, and 8x over 8x, well, it's the same thing over the same thing, which is just 1, so minus 1. So 8x times 3x minus 1. For letter C, if I take a look at the 6 and the 12, the biggest number that divides 6 and 12 at the same time is the number 6. So 6 is my GCF, and I just divide each term by 6 afterwards. So those will cancel off, giving you a single x, and 12 divided by 6 is just 2, so minus 2 in the brackets. Moving on to letter D, here's my 2 and here's my 8. The biggest number that divides 2 and 8 at the same time is the number 2. And then let's take a look at the variables here, which is smaller, x squared or a single x. Well, the single x is smaller, so that is my GCF, the 2x. And then I divide each term by the GCF and then just do the math here. The 2's cancel, x squared over x is a single x. These x's cancel, 8 divided by 2 is going to be 4. So 2x times x plus 4. Okay, let's move on to letter E now, and letter E is not too bad. I have a 4 and a 10, so the biggest number that divides 4 and 10 at the same time is the number 2, so 2 is the GCF. So now I can divide both terms by the GCFs, so 4 divided by 2 is 2, so 2x, and then plus 5 is my final answer there. For letter F, for the 10 and 35, the biggest number that divides 10 and 35 would be the number 5. And then I take a look at my variables here. Which one's smaller, x squared or x? Well, x is smaller. And I can divide both terms by the GCF, which is 5x, to figure out what goes in the brackets. So 10 divided by 5 is 2, so 2x. Those x's will cancel off, and 35 divided by 5 is plus 7. So final answer there is 5x times 2x plus 7. Okay, moving on to letter G, let's take a look at the numbers here, 10 and 15. The biggest number that divides 10 and 15 at the same time is the number 5. And then I'll take a look at my variables. I have an x squared and an x, so the smallest one there is just a single x. And then if I take a look at the y variables, what's smaller, y or y squared? Well, a single y is bigger. All right, so after that, we can separate brackets, and then I can divide each term by the GCF, which is 5xy. Okay, all right, so 10 divided by 5 is 2. X squared over x is a single x, and the y's will cancel off. And then I have negative 15 divided by 5, which is negative 3. The x's cancel off. Y squared over y is just a single y. So my final answer is 5xy times 2x minus 3y. All right, let's move on to letter H. For letter H, I can just focus on the numbers here. And the biggest number that divides all three of those numbers at the same time would be the number 3. So I can divide this by 3, divide that by 3, and divide that by 3. So inside my brackets, 12 divided by 3 is 4, so 4x squared. 9 divided by 3 is 3, so minus 3x. And plus 15 divided by 3 is 5. So 3 times 4x squared minus 3x plus 5. All right, let's keep on going with the questions in this section here. And for the next problem here, let me just focus on the numbers again. And the biggest number that divides into all three of those at the same time would be the number 3. So I can divide all the terms by 3 because 3 is my GCF. And then we just do the simple division steps here. So the 3's will cancel, giving you n squared. 12 divided by 3 is 4, so minus 4n squared. And 12 divided by 3 is also just 4, so plus 4 on the last one there. Now, although this answer is correct, if you want to combine these like terms, feel free to do so. So that would be a negative 3n squared plus 4. Okay, so move on to the next one here. Now, for the next one here, if I look at the 9, the 4, and the 12, there's not a number that divides all three of those numbers at the same time. The only number that works is 1, so this one we can't factor. We can't factor it because there's not a number bigger than 1 that can divide the 9, the 4, and the 12 at the same time. Okay, the next one's K, and once again, let's take a look at the numbers here. A 2, a 3, and a 5. So the biggest number that divides all three of those is 1 once again. All right, so there's no number that divides 2, 3, and 5 at the same time except for 1. However, we do have variables. Each term does have a variable, right? So all three terms have the variable x, so that's the common term, I guess. So the common factor here is the variable x, and all we have to do is look at the smallest variable of x. So there's 3 here, there's 2 there, there's 1 here. So x is, this single x would be your GCF. So now I can divide all the terms by x. And this one's not too bad. It would be 2x squared minus 3x plus 5. Right, so if the bases are the same and for dividing, we just subtract the powers. So final answer there is x times 2x squared minus 3x plus 5. Okay, a few more questions to go here. And for this next one here, there's a 13, a 26, and a 39. So if I take a look at all three of those numbers, the biggest number that divides all three of those numbers at the same time is the number 13. And then all three terms have the m variable, and the smallest variable that we have here is just a single m here, so we would pick that one. So 13m is my GCF, and that means we just divide every term by the GCF. Okay, so back to the first term, 13m divided by 13m, same thing, that just gives you a 1, plus 26 divided by 13 is 2. And then m squared over m is a single m. 39 over 13 is 3, so minus 3. And m cubed over m is m to the power of 2. So my final answer is 13 times 1 plus 2m minus 3m squared. And for the next one, I need to focus on the numbers only because every single term does not have a variable. And the biggest number that divides into 17, 34, and 51 at the same time is 17. So 17 is my GCF. So 17 over 17 is 1, so this will be x squared. 34 over 17 is 2, so plus 2x. And 51 divided by 17 is going to be 3, so plus 3 at the very end to finish off. Okay, let's move on to letter N here. And for letter N, I'm just going to erase this to create a little bit more space here. Let's take a look at the numbers here. There's an 18, a 12, and a 24. So the biggest number that divides into 18, 12, and 24 at the same time would be the number 6. 6 is the biggest number that divides all three of those yellow numbers at the same time. All right, now let's take a look at the variables now. M squared, and an m squared. Well, since they all have an m squared, I mean the lowest number of m's you can take out is just going to be the same thing, m squared. And then all of them have a variable n. So the smallest number of the variable n's that you can take out is n squared over here. So we would put n squared over here, and that would be our GCF. Okay, so our GCF is 6m squared n squared, and that means I can divide every single term by 6m squared n squared, 6m squared n squared, and another 6m squared n squared. All right, and now we can figure out our expression in the bracket by doing the division statement. Okay, so 18 divided by 6 is 3, so I have a 3 here. The m's can cancel off, and n to the power 4 divided by n squared is just n to the power 2. And then I have negative 12 divided by 6, which is negative 2. The m's will cancel off, and over here I have a single variable n. 3 minus 2 is 1, so n would be there. And then I have 24 divided by 6, which is plus 4. The m's will cancel off, and the n's will also cancel off, so the last term is just a 4. Okay, so that concludes this very first video on greatest common factoring.